And this is how we're going to be taking our notes for the entire year. Your homework assignments will include a video and guided notes, and you will be expected to watch the video and fill out your guided notes so that when you come to class, you're all ready to practice what you've learned. So here we go. This is our first lesson, classifying rational numbers. Let's look at it together. It says the following locations have been organized below. Use the diagram to discuss the questions. So you'll notice there are 3 boxes, and inside the innermost box is Houston, and then Harris County, and then Texas. It says, if someone is from Houston, then are they also for Texas? Why or why not? Well, one of the things you have to realize is the most inside box is the smallest location. It's the most exclusive location. Okay? So if we were to think about our school, everyone can get in the school. Okay? And then everyone has a math class, right? That's a requirement. But only certain people, the ones Miss Williams chose, will get a honors math class. That's the most exclusive club in the school. So if someone is from Houston, then are they also from Texas? Well, the answer is yes, because Houston is located inside the state of Texas. So the next question says, well, is someone from Harris County also from Houston? Okay? And in this case, the answer is not always. While someone from Houston is from Harris County, there are other cities located inside Harris County that people can live in. Okay, if someone is from Austin, then which part of the diagram do they belong in? Well, if they live in Austin, they don't live in Houston, right? And if they live in Austin, they live in Bexar County, I think. I don't know. I don't know geography very well. I'm thinking it's Bexar, though. It's not Harris County, because Harris County is Houston. But if they are in Austin, they do live in the state of Texas, because Austin is the capital of Texas. So they live in Texas, or they are located in the Texas part of the drawing. The number system classifies numbers based on their type and characteristics. Okay, we're going to move on. Okay, we're going to look at the different types of classifying numbers. So we're going to start with whole numbers. And these are the positive counting numbers starting with the number 0. Examples include 0, 1, 2, 3, 4, 5, etc. Integers are the set of whole numbers and their opposites. For example, these would be 1 and -1, 2 and -2, 3 and -3. So when we write these, we are really looking at the negative numbers because the positive numbers are up in the whole number. So I would do -1, -2, -3, -4, -5, -6, ... Rational numbers are numbers that can be written as fractions, terminating decimals and repeating decimals. So we're going to put repeating here. And we have examples like, I don't know, 5.6, 3/4, 1/2, 1.22222 repeating, 3.75, -3/5. All of these are rational numbers. Make sure you're filling out your guided notes. Okay, we're going to label the different parts of the number system diagram below. Now, I like to remember it this way. Inside is whole numbers, and then next is integers, and outside is rational numbers. And I remember that with these three letters, W-I-R, just like that. You'll see me talk about W-I-R. It always starts on the inside and goes out, where the most exclusive would be the whole numbers and the least exclusive are the rational numbers. So is it possible for a number to be both a whole number and an integer? Why or why not? Well, let's think of the example number 2. 2 is a whole number, right? The definition of an integer is a whole number and their opposite. So a whole number is also an integer. Remember, if we take the picture of our school, the school is rational numbers. That's the least exclusive. We all go here, okay? And then the second box would be, well, everyone takes a math class, okay? The most exclusive box, though, is you're taking a math class with Miss Williams. That is your most exclusive. So we are the exclusive club. Math in general would be the middle box, and then school as a whole. So a whole number, oh gosh, look at me. A whole number is also an integer. Okay, you're going to use this graphic organizer to correctly place each of the following values. I'm going to help you with one of each. I expect you to come to class with this graphic organizer finished. A whole number, I'll give you one of them, is 15. An integer, I'll give you one, -37. And a rational number, 1/8. You're responsible for filling out the rest of this Venn diagram. And finally, you're going to work on this and bring this ready to class tomorrow. It says a set of numbers has been classified below. Determine which numbers are incorrect and justify your response below. So for example, -1.0, that is incorrect. And it is wrong because whole numbers are never negative. It should be an integer. Okay? So you're going to give me the correct location and why it is wrong. Okay, once again, you'll have this done when you come to class. I will see you guys in class. I hope you have a great evening, and I will see you soon.